Hello dear student, good afternoon everybody. Today we are going to discuss about the furnaces used in metal casting. So there are different types of furnaces used in foundry shop. The furnace is an equipment used to melt the metal, and different furnaces uses different technology. Some furnaces use the coke fire, some furnaces use the oil fire, some are gas fired, and some uses electricity in order to heat the metal and to convert that metal into molten form. So the foundry is designed in such a way that it consumes less heat and fuel as possible in order to melt the metal. So these are the various furnaces using metal casting. Number one is crucible furnace. Number two is cupola furnace. Number three is induction furnace and reverberatory furnace. Those are the electrical furnaces. Electrical arc furnaces using. So one by one we are going to discuss the construction features of the various furnaces. So first one is crucible furnace. So crucible or ladle is used to take out the molten metal. So this is the block diagram of crucible furnace. So this is the cover, chimney is there, this portion is called as the ladle. These are the refractory lining, bricks lining is there, air blower is there, it blows the air inside this. These are the lining of cokes, and this crucible contains the metal, and these cokes are fired, and it is converted into, this metal is converted into molten form because of the heat of the coke. In some furnaces oil is fired here in order to increase the heat and heat the crucible, and this metal is converted into molten form. And remove this cover after it reaches certain temperature and pour it into the previously prepared mold cavity. So crucible furnaces means what? These furnaces melt the metal without direct contact with the burning of fuel mixture. For this reason, they are called as indirect fuel fired furnaces. Sometimes they are called indirect fuel fired furnace. Crucible furnaces are mostly used to heat the or to melt the non-ferrous metals and alloys. The metal is melted in a crucible, which is a refractory vessel made up of graphite, silicon carbide, or some other refractory materials. So, what are the stages in crucible? Used for non-ferrous metals. Furnace is of cylindrical shape, also known as pit furnace. First, to make a deep bed of coke in the furnace, burn the coke till it attains the state of maximum combustion. Insert the crucible in the coke bed and remove the crucible when the melt reaches to its desired temperature. So, oil fired and coke fired furnace, the basic difference is that in this oil is used to fire the to melt the metal. Oil is used. This is the block diagram of electrical furnace. There are three electrodes. Carbon electrodes are there, non-consumable carbon electrodes. Supplied with electricity, power is supplied to this electrode. When this electrode comes in contact with this metal, arc is generated, and this arc contains maximum amount of heat, and that heat is responsible to melt the metal. After this metal reaches to its particular temperature, molten form, take this molten metal in the crucible or in the ladle, and you take this crucible to the molding box. So this is the electrical arc furnace. Cupola furnace is also there. The cupola furnace is cylindrical in shape, used to melt the iron and ferrous alloys in foundry operation. This is the block diagram of cupola furnace. It is cylindrical in nature. Inside lining, inner linings are the refractory bricks lining. It will sustain the high temperature. This portion is the mixture of ferrous metal, carbon, coke, and layers, different layers of carbon, coke, metal, like that. And it is a blower, and it is burning will start, and it will convert this metal into molten form, and this molten metal is collected from this side in the ladle, and on this side there is a slag opening to remove the slag. So this is all about the cupola furnace. This is the spark arrestor in order to arrest the spark from this portion, so that maximum heat is utilized inside the furnace. This is the charging door from where you are going to pour the coke, flux, carbon, then metal inside this charging door. So this is all about the cupola furnace. So cupola consists of vertical cylindrical steel sheet and lined inside with the refractory bricks. The lining is generally thicker in the lower portion as compared to upper portion because the temperature are higher than upper portion. In lower portion temperature is higher. So there is a charging door through which coke, pig, iron, steel, scrap and flux is charged. This is the charging door from where the mixture, scrap, metal, coke, flux are poured from this side. There is a charging door through which the coke, pig, iron, steel, scrap and flux is charged. The blast is blown through the tubes. Air are blown. Air is supplied from this. There is the water pump also to pull this molten metal or this mixture. So hot gases which ascends from the bottom preheats the air in the preheating zone. Cupolas are provided with a drop bottom door through which debris consisting of coke, slag, etc. can be discharged at the end of the melt. A slag hole is provided to remove the slag and charged through the tap hole. Molten metal is poured into the ladle. In this case, this is the opening port or tapping spout. From this, the molten metal is taken in the ladle. So this is the ladle. So this is the block diagram of cupola furnace. So this is spark arrestor, cylindrical cell. This is the stack. Particular height is there. Then this is the charging door from where you are going to pour the that iron mixture of metal, coke, flux from this. These are the refractory linings. This is the spout from where slag is collected. Slag opening. This is the molten metal opening from where it is collected in the crucible or ladle. So this is all about the cupola furnace. This is the induction furnace. These are the various copper coil, induction coils. These is the refractory materials, cement, and this is the crucible. Inside this crucible, you are heating the metal, and when you convert it into molten form, take out this crucible from this furnace and pour it into the previously prepared mold cavity. Now, how you are going to select the furnaces? So, to make the furnace selection, these are the various points to be considered. Number one is economical consideration. Economical consideration means cost. Cost is also taken into consideration. Then composition and melting point of the alloy to be casted. Then control of the furnace atmosphere to avoid contamination of the metal. So no reaction will take place with the molten metal. So some control atmosphere is required. Some control atmosphere is required. Then capacity and rate of melting required. Capacity and melting required. Environmental conditions, pollution free. That must be pollution free. Availability of the power supply and cost of fuels used for heating the metal. Then ease of superheating the metal, then type of charged material that can be used. So these are the various factors to be considered while making selection of furnace. So this is all about the metal furnaces. In coming lecture, we are going to discuss about the casting defects. So this is all about the furnaces. In today's lecture, we have discussed about the cupola furnace, induction furnace, crucible furnace, and electrical arc furnace, induction arc furnaces, induction coil furnaces. Their construction features, working, how they will work. Then, at the last, we have discussed about the furnace selection. What are the points to be considered? What are the factors to be considered while making a selection of furnace for metal casting? So this is all about the metal casting furnace. So in coming lecture, we are going to discuss about the casting defects. So okay, thank you.